Welcome to It's a Controls Problem, where we do precision guesswork based upon unreliable data given to us by those of questionable knowledge. I'm your host, Charles Johnson. Hello, welcome. Charles Johnson, host of It's a Controls Problem. I'm here with my producer and partner extraordinaire, Matthew Vanberg. Hello, Matthew. And we have here a special guest, Kenny Seeton. I believe Seeton is your last name. Is that?
That is correct.
And you were with California State University, right? CSU?
I am with one of the 23 CSUs, Dominguez Hills. Yes.
Dominguez Hills. And what is your role there?
So my role is the Director of Central Plant Operations and Strategic Energy Projects.
Okay.
Basically, I'm the Chief Engineer, and I get to play with all the toys and energy.
I do like playing with toys. Toys are very nice. So do you just want to give everyone a history about yourself?
Yeah. I've been here since 2011. Before that, I was at Hostess Cupcakes, fixing equipment that makes Twinkies and cupcakes. And I thought that I would be bored if I took the job here, so I almost didn't take it. Since 2011, I've just been moving the needle every chance I get, a little bit at a time, until now we're about 70% greenhouse gas reduction since 2018. Got a crew of 9 to 10 people, depending on the year. And we handle all the heating and cooling problems for the campus, running the central plant, also all the buildings. And as an energy manager, everything we do in the buildings is saving energy, so it's all one job.
Okay, well, definitely welcome to the show for sure. You're our first. You're actually our first guest that is not associated with a vendor or their own company. So this is it's actually kind of exciting. Now we get to bring people who are actually working with the systems in and getting their experience from it. But Ken, let's go ahead and let's start from the beginning. What was the defining moment in your early years that drew your focus to automation and engineering?
It's a great question. Defining moments. I don't know that there was one defining moment, really. When like I said, when I got here, I didn't know anything about building automation, right? I came from PLCs and high-speed automation. When I interviewed, they asked me what made me qualified for this job. And I said, well, look, how hard can it be? You only have 5 pieces of equipment, right? And he's like, the AVP of facilities, like, what are you talking about? So, well, you have an air handler. Oh, we have like 27 air handlers or whatever. And I said, yeah, but an air handler is an air handler, baby. It's just one, it's a box with a fan in it. And whether it's direct drive or belt drive or whatever, I said, that's one piece of equipment. You got what? 2 thermostats, maybe 3 if you got a 2-pipe or a 4-pipe. I said, anything that fits in the palm of my hand that is not a computer, I got no problem figuring out, And so they had done they call them MBCX, monitor-based commissioning, right? So they hired an engineering team to look at a building and create this giant 8-page punch list Excel document. And they handed me that and they said, look, take care of this. And I looked at it and I was like, oh, okay, well, now I don't know anything about buildings, right? Move the coffee pot, move the thermostat from behind the coffee pot. I'm like, oh, okay, that's easy to fix, right? Why? Oh, because there's heat off of that and it changes things. Fix the control valve on the air handler. And so that was a classic one, right? I went over there, big 50 horsepower supply fan, 25 horsepower return fan, 3 air handlers. The control valve had a pair of vice grips on it. And in the wintertime, they moved it to one position. In the summertime, they moved it to another. And I asked the supervising BSE, who my second in command, I said, hey, look, how complicated is it to fix that? He's like, well, what do you mean? I said, well, do I have to cut the pipe apart and, change out that doohickey, like, that chingadera? What is that thing? I don't even know what it's called, right? And he's like, the control valve? Yeah, there you go. What, that thing, right? He says, no, we don't have to change the control valve. I go, oh, so then it's just the chingadera that fits on top of it, right? The actuator, right? He's like, yeah. I go, well, is it expensive? And he's like, I mean, what's expensive? I don't know. Is it $50,000, or is it 3,000? He goes, it's like $800. And I'm like, can you buy one? He's like, yeah. I go, well, can you order one? And we put that on, and all of a sudden now your water valve opens and closes as it has to. That might have been one of the defining moments, right? To where it's like, wow, this isn't complicated, right? Somebody built this at one time to specs to work a certain way. Mm-hmm. Because nobody did anything, now all of a sudden the building is labeled as this problem building and nothing works. And so my goal was just to put it back to where it was beginning. And as I did that, I learned more about the operation and what affects what, and the chill water saves the central plant, and the dampers that are always, stuck open, affect the all of that stuff. And so that punch list was like my Bible and my thesis on what to do to, become a smarter, that turned me into the building person. And from there, it was just, what else can we do, right? Once I understood the game and I saw the savings in that one building, I wanted to do it everywhere, right? And I like mechanical stuff, right? I like to play with the toys and stuff. And so in the beginning, it was playing with that stuff. And then it got into the controls, right? Then we had like 4 or 5 different control things. One building was Train, and one was JCI, and one was Allerton, and one was Andover. And it was like, well, this can't be good. We need to centralize, right? We need to standardize so that everybody understands how to work on the system. And that opened my eyes up to the controls. And then I started seeing, as we, upgraded the JCI system to, from the old DOS system that was here in 2011, because nobody did anything. And I started seeing what the capabilities were and understanding, the logic blocks, and working with smart control technicians as we started moving things over. Then it opened up my eyes to the control side of thing, right? And it's like, yes, we can open, close, but we could also slowly open and close, and we can, use the trend data. It just kept growing from there, honestly.
So, since you worked in the food industry automation before you became in facility, into actual facilities there, what are the key differences between the systems like you were working with in the food automation or in the food industry automation versus what you are handling now? And were some of those experiences that you had there, were they just the foundational experience that you shaped your approach to operations?
The systems were very different, right? We were Allen Bradley. You could plug in anything to an Allen Bradley system, right? It had I/O and analog and different things. And when I got here, everything was this crazy proprietary stuff that it had to be this device and it had to talk to this thing. And I couldn't understand that part. It made me crazy. I'm like, why are we spending all this money on this stuff? We could just put an Allen Bradley, put it on the wall and program. And my boss says, okay, do you have time to do the programming, all that it would take to do a building? I'm like, no. Well, your people don't even know what that is, right? Because they're all HVAC people. And so that was a rude awakening, right? But the one thing at the bakery that I learned was that it doesn't matter what you do as long as you can make the line run. Mm-hmm. It's broken now and it's costing somebody $1,000 a minute. So doesn't matter what you do, you can't make it worse, right? So you do things and you make it better. And you steal from wherever you have to make that work. And so, and you have to do it, while the production crew goes to break, you got to change out that 30 horsepower motor, right? And so you get really good at figuring out what it takes to keep things operating and going. Now, I got here, that was another huge frustrating thing, right? A motor burns up and it takes 2 days to get another one and nobody's concerned. They're just like, yeah, it's okay. It's just the return fan, the building will run. And me, I'm just bouncing like, wait, this is no good, But at the same time, all the things that I learned there made it so that I wasn't afraid to push buttons, right? I love to push buttons. What's the worst that can happen, right? Usually something would just shut down. Well, how often do things shut down all by themselves anyway? What do? Our job is to start it back up again, right? And so I was never afraid to do things, right? And I think that people that start off just in this or only go to 4-year degree mechanical engineer, or, and then they come out, they have all these preconceived notions of what they can't do because that doesn't work, or we're told stay within the parameters. And my parameters were, I turned it until somebody complained or the unit shut down.
Yeah.
Right? Ken, how did you figure out you could run 110 to 120 degree water, in the summertime, right? Just enough to keep the valves warm, right? I'm like, well, I just turned it down until people complained. It's like, oh shit, that's too low. Time to turn it back up again, right? The weather is changing. How did I find out that I could shut off the entire plant at nighttime and just push water through the distribution loop and make it through the entire night without a server room overheating, right? Well, we just did it, The first time we did it, we shut down the loop too, because I didn't know any better, right? So, hey, what if I shut everything off? How long will that room go before it warms up? About 3 minutes, But if you have 60 degree water running through the loop, 65 degree water running through the loop, they're still removing heat from the space, and that space kind of plateaus out, and eventually it hits 74, 76 degrees. Oh, okay, let's turn everything back on again and do it. There's no manual for that, right? It's just, you got to tweak it and push the buttons. And then once you kind of figure that out, then I go to my control specialist and say, hey, I learned this new thing. Can you write a sequence of operation that says, hey, look at these 3 server rooms, and if they're at this temperature and the tonnage is below X, shut everything off except for the pump. And when one of them gets hot, just turn it all back on. First month, we didn't sleep real good every night, But after that, we've been running it for a couple of years now, that sequence. So those, and I think that my mentality of being able to do that came from, look, I don't care what you do, make it run. It's for real baling wire, duct tape, and cardboard, to keep things where they're supposed to go.
What so with your particular facility, and how many buildings do you have? Just curious.
Yeah, there's probably like 15 main buildings, right? There's some trailers and stuff like that. We're about 1.5 million square feet of conditioned space from the central plant.
And what, so do you have, I know that you had mentioned that you had a few systems before, but are you all under one system? Like, are you just under Metasys?
I have one building that was a newer building when I got here. It just came online in 2011, was an Allerton building.
Okay.
I haven't converted that yet. It's, the hardware is still running okay, but we will do that eventually. And it becomes the devil, right? Because they're all evil, right? Controls and stuff. But if all of your guys understand that system, then that's a win,
Was there a particular feature or function of you're under Metasys now, right? Completely, is that right? Okay.
Yeah.
So was there a particular thing that Metasys did that you were like, I know you just mentioned about the devil you know versus the devil you don't, which is really important as well.
Right.
But like, was there one thing you're like, you know what, we're going to stick with this. This is what I like.
The campus was probably 65% Metasys, so that helped the decision.
Mm-hmm.
I went to lunch with about 4 different control companies, right, to see who I liked the best, who was going to give me the most support, and at that time, it was JCI.
Okay.
And so that made the logical sense, right? We didn't have to change out, the hardware right away, right? We just had to upgrade the stuff, and then the other buildings, and so.
So you just have like a bunch of NAEs around and stuff like that?
Yeah. Now they're turning into SNEs, and, and then there used to be DX1000s when I got here, and, so pretty much don't have any DX1000s anymore,
Mm-hmm.
And yeah,
I remember the DX9100. That was those were also fun times. Those controllers are special for sure.
They were, but they were good too, right? The ones that had the display on them. If you're lucky, right, you could go in there and be in the mechanical room and not have. Back in the day when you didn't have cellular and Wi-Fi coverage in the tunnels and stuff, right? You can't call back up to the control room and tell them to make these changes. Like, okay, let me just do this and see what's going on in this thing. And that's changed a lot too. Right now, like that was one of the first projects I did with rebate money in 2011 was put repeaters down through the tunnel because campus IT said, well, look, Ken, that's not the campus proper. We take care of the campus proper for the students and stuff. But if you give us this much money, we'll put some repeaters down there in the tunnel for you,
Okay.
So, and it was fun times back then, right? For all of us, right? Like, I mean, has anybody ever had to had to try and troubleshoot something, go up the stairs to the outside, call tech support, wait forever, get a hold of somebody, get told, try this, hang up and go back down and try it. It doesn't work. And then you got to go get in line again,
Yeah,
Fun days.
those are times where, especially in previous life, one of the first companies I worked for was in Maryland, and we were on a Bethesda Naval, and so the university is called USUHS, and so it's for Uniformed Health Services, but most of the buildings that you went into had no phone systems whatsoever. So yeah, by the time that you were trying to get a hold of something, like those days right there were absolutely real for me, taking the amount of time there. So, can you give us pretty much a day-to-day life in Kenny's world?
It's a fire hose for most people, right? It's like I come in, I meet with the team, take care of the administration stuff, right? What was done before? Is the timekeeping done? Is that kind of stuff done? Every day is different, though. It's like I don't have a typical day. I had a fellow, right, energy fellow for the last 10 months. She just left a month ago, and it was so funny because they had her at there was a conference, sustainability conference, and they had some sustainability people there that work on the campus, and she was there. And they said, what's a typical day? The sustainability people, well, we feed the chickens in the morning, and then we go do this, and then we do a tabling event, and then we check on this, blah, blah, blah. And then they asked my fellow Maddie, and they said, well, what's a typical day? She's like, there's no such thing as a typical day with Ken, right? It's like one day we're checking meters, and one day we're meeting with this IT person and this new AI person and this, putting presentations together to speak at an ASHRAE event or an Edison event, going through the SkySpark report and finding those top 10 things and seeing if I can get my team to, find time to go fix those. Sometimes, I'll have, I always sound like a cartoon character, like the light bulb goes off on my head on the weekend or in the shower, right? And I'm like, oh, and I rush back to work to my control specialist, and I'm like, Jose, look, we're doing this. What can we do this? And it's like, and if we do, here's the formula, right? And I spend 20 minutes spelling it out and type it in. And then he goes, well, yeah, Ken, that's just a span adjust. We just have to put the high and the low and the other one, and it's done in 5 minutes, And I'm like, that's cool. Why aren't we doing it yet? And then, you monitor that, right? And you're looking at the trend analysis, and you're seeing if what you decided to do was good. I'm really big on keeping the place looking nice, right? And so it's like we're, walking. I want my mechanical rooms to look as good as the central plant, and my central plant looks really nice, right? And so we do tours once a year. I do an official open house for the campus and stuff. And so setting up for that. And then I do half a dozen other ones where I'll do lunch and learns for organizations and engineering firms and, taking them down through the tunnels and that kind of stuff. Then I'm talking to my SkySpark third-party, engineer and saying, oh, okay, look, I just did this. Can you monitor this data, right? And then let's brainstorm and see if that works. So I think there's a lot of brainstorming and team development. To me, it's really important that the team has the same vision that I have, right? Because let's face it, I'm going to be gone in 5-6 years or whatever and retire, and I want this place to run as well now or then as it does now. Without me pushing it. So now, this last couple of years is my push is to work with one of the BSEs and say, hey, look, you know what? You're going to be the new energy champion, whether you want to or not. Hopefully you do, right? And he does, right? So it's like, now I need to start focusing on, all right, this is how we look at the trends, and this is the data. And he's real technical. So now he's doing stuff that I don't do, right? It's like, we need to create BACnet ID, right? So how do you not get duplicates? And we're developing this plan. Like, okay, well, if we use the building number and the floor number and the whatever, well, he typed into ChatGPT and asked it, how do we do this? And it gave him an Excel formula that says building number times 1 million plus, this, and you end up with this 8-digit number. I'm like, dude, that's so awesome, right? And it didn't work at first for him because ChatGPT doesn't always give you the right format, and so he asked me, hey, can you look at this? I'm like, oh, you got to take out all the spaces and then, here you can do this. So I think I spent a lot of time mentoring and trying to. Now, I'm not a programmer, right? Like I told Matthew, look, I'm not a controls expert. I'm not an expert on a lot of things, right? But I have really good common sense. And so, like kind of you were talking about in the beginning, right? You got to understand how stuff works before you can start using these things to do it for you, right?
Yep, absolutely.
And these things don't always give you the right answer. Like the Excel sheet, it said, copy and paste this into Excel, and there you go, and it's like, well, he's never done something like that. It just didn't work. And how you don't know what you don't know, right? And so it's important to work as a team because you don't know what you don't know, but maybe that guy does, and so fostering that is important, right? And I go to way too many meetings, right? Once they gave me, I used to be called the central plant manager / energy manager, and after I got the Kenergy nickname by the budget director, and a couple more, about 2 years later, I said, hey, wait, I need a raise, and they wouldn't give me the raise without the director part of the title, which means, oh, wait, 20 meetings wasn't enough. You need 40 meetings, So there's that.
When your job description becomes that's usually where you're like, oh, okay, I do a lot now. Yeah, absolutely.
But I do more, but I wouldn't change it for the world, right? I think I'm probably, one of the 1 percentiles that's like super happy at what I do, right? Work became the hobby, Once I started seeing what it took to move the needle, it's like, I got solar powered golf carts at work, right? And first I built a remote control solar powered car, right? And then it's like, oh, wait, if I can do this little, AA thing that runs on solar without the batteries in it, why can't I do that to the golf cart, right? If I can do solar at my roof and batteries in my garage to run my house from, eBay and Amazon, why can't we build out this net zero center at work, right? And then why can't I get my team involved? And here's all the data. And now we have, 5 rooftops at the campus that, I was able to convince them to do. And we've got, 4 megawatt battery on the campus. And when you understand it, then you're able to sell it. And now I'm trying to get more and more and more. But I'm never done doing the research and stuff. It's like, what else is out there, right? I've learned that I take a lot of these sales calls, and the more popular you get, the more sales calls you get. But you don't learn anything new. Sales people are used to being told no. You just got to learn to say no, right? If it's not the right product for you, but this product might not be right, but you might learn something from it that you can use in something else that you're doing. And so it's important to look at different objects and ideas, and then it's really important to share. Like, me taking time to do this podcast, right? I don't think we should all have to reinvent the wheel. There's a lot of really cool stuff out there, and so many people are afraid to talk about it. Anyway, that's my karma to give back to the world is to share the things that work for us.
I resonate with that. I resonate with that statement a lot. You'll see on my LinkedIn that I show a lot, and I give a lot of knowledge, and I give a lot of stuff away for free. And the reason being is that, well, if I figured it out, then someone else doesn't have to right away. But if they're interested in doing it, now they can see what I've done, and then now they can start playing with stuff. So. As an aside, I'm not a fan of UI and UX whatsoever. I hate it. Big visual things, not my style. I'm actually 100% colorblind, so it's very difficult for me to do that. But I wanted to kind of push my students into making better graphics. And so I actually now have entire pages I made that actually don't use any graphic files inside Niagara whatsoever. It's all just HTML stuff that I've been doing, but I've been giving them away. And so one of the students actually took it from my classes, already started to use it. And I was like, whoa, first off, you're really overcomplicating this right now. Like, this is your first project and now this is how you want to go. Okay.
Yeah.
But I think that kind of stuff is really good, which leads me to my next thing now, because I think you and I actually have this. You and I actually have a very similar mantra. But Matthew was telling me about this mantra you have: is if better is possible, good is not enough. And so, can you tell us about the philosophy behind that and how it's guided your decisions and leadership style throughout your career?
I learned that from a 365-day quote calendar, the Rolodex that they used to have, right? And it was
okay.
I got it for Christmas or a birthday or something 25, 30 years ago. I don't know. I was at the bakery, and I had it on my desk. And when I saw that one, it was like, oh my God, right? That is me, that just makes so much sense, right? And so many people, it's good enough, right? It works, it's fine, and the mechanical logic part of me looks at something and says, if you put the hinge, here, then this is going to work better, right? Or if you do this is going to be better. And it's like, it doesn't have to be life-changing better. It just has to be better, right? And so those little things make somebody else's life better. Maybe yours, maybe somebody else, right? And so at the bakery, it was a big deal, right? It was like, look, if we weld this here or if we make a hinge here, or if we do this, this is going to be easier to clean. It's going to be easier to do this and that kind of stuff. When I got here, it's like the same thing, right? Well, nobody can see that, boss. Why do we care? I'm like, well, I'm looking at it right now. So how can you say nobody can see it, right? If it looks better, then you're not afraid to get next to it and work on it. If it looks better, then you can see the problems. You can hear the problems. And so I don't even know who said it. I did research one time and something said it was maybe Benjamin Franklin, because, he gets quoted with doing a lot of quotes, right? But I never could find for sure who said it. But it's on my tagline for my signature on my email now, and it's just, it's hard for my employees sometimes because they'll do a job and they're so proud of it. And I just tunnel in on, why did you put the nipple there? It's like, instead of welding it down here, and they're like, okay. I mean, it still works. I go, I'm not arguing that it still works. I'm like, on the next one, we should put it over here. Right. Because it's better. And so, yeah, I'm the guy that goes to the doctor's office. My wife, she was a long time ago, we went to the doctor's office. She sits up on the table and I hear a rattle. And then I look and I see the bolts loose and this, and I'm over there like hand tightening these things that are about to fall out. She's like, what are you doing? I go, well, this thing is messed up. You got to fix it, the memes were, I think Tony Mormimo is always posting stuff, right, about the couple that's sitting at the restaurant and she's got all these handbag thoughts or whatever restaurant or I love you. And he's like, wow, why did they do that on that HVAC duct?
Mm-hmm. Yep.
So those are just how I'm wired. And that goes with it.
Yeah, I'm the same way. I think I like to push people because sometimes they don't understand the the level of potential they have until they get pushed to that limit. Some people stay within their comfort zone the whole time. And even for me, there are times where I start working on something and I'm like, okay, well, it's not working now. And then once I get at least one part working, because what will happen is if I have nothing working before I go to bed, I can't sleep. It will haunt me until I get up and do something. So then there are times I've literally started from scratch again. Like, you know what? I'm just deleting the whole thing and I'm going to start from scratch again. They're like, isn't that a lot of work? I'm like, well, if it's not right now, it wasn't good then. I'm not doing that. And so same thing, I believe that just because you have something that works doesn't mean that it is the best that it can be. And sure, you may not have time to do it there, but in the next project, you absolutely need to do it that way. We have a few younger guys that I work with right now. And I'm kind of getting them some mentorship, and they'll send me something like, "Hey, yeah, I did this here." It's like, okay, but why didn't we do it this way? Oh, well, we didn't. I didn't know that was possible. Okay, well now you do. So now we'll go ahead, and then they get that part there, and I'm like, well, how about that? And they're like, really? I was like, yes. Like you're going to learn. You are absolutely going to learn that way. So you had mentioned about I guess you've done a few solar projects on the campus facility itself. Is that correct?
Yeah, we've done. Go ahead.
So when we're talking about so part of that energy efficiency that you're talking about, obviously it's a critical component, in your role. And so besides that, are there some other impactful or innovative projects that you've implemented there that have really been successful? And what were some of those challenges and even successes that were associated with them?
There's probably about 4 that are top of the list. Belimo smart energy valves are one of the one of the early ones, right? Why would I need to put a meter, like an Onicon meter, and then a control valve when I can do one thing that does everything and gives me all the feedback and everything I need to know, right? I don't pump as much water through the campus since every air handler now has one of those on it. So that was one of them. Another one was I was a real early adopter of Enlighted ED that got bought by Siemens that just now got dumped, automated smart controls for lighting, right? That talks BACnet, that now I can control the building space, not just the lighting, but turning off the air conditioning when nobody's there, right? So that was like, you do a pneumatic to DDC, change out the LED and go occupancy-based control, and there's like a 50% energy savings on that building just right there. That was a really big thing that when I saw those results, I had to do more and more and more. Just recently, we did probably the largest heat pump project on the West Coast. I put in 21 30-ton heat pumps. I got rid of 96% of my gas usage to warm the campus up. I need to do more solar now to offset that, but I don't have the gas anymore. And then the exciting one was I met Keith Gibson a while ago, who does Facile.ai, and I worked with him as the guinea pig, right, or the R&D site for that technology for chiller optimization. And after it had been running for a while, and I pulled up the trend data that showed 2 years ago, and then this year, and this year the line was half as high as the previous one. When our chiller efficiency started averaging 0.43 or something like that, and we could show a 48% increase in efficiency. That was like, wow, this is really cool, right? And so now I'm super excited for what's next. Like now I'm working with them and whiteboarding out. Okay, well, if we do this and we look at average temperatures in a building and the interior versus the exterior, and this air handler controls this part of the building, and how do we get true optimized start stop, and how do we control the discharge air temperature, and what about these people that don't have really, really smart control people in the chair that can write that program, which they can't to the AI level, but there's simple things we could do that a lot of people don't do because they don't know, or they don't have, or maybe they know, but they're handcuffed to a control company that they have to pay a stupid amount of money to do some simple thing. And so that's getting super exciting, in this last year now. And I've been with them for like 5 years, I think. We met right when COVID hit. And so that, I can't even talk enough about that, right? It's just the AI, the fact that, you can take this simple wet bulb plus 5 degrees for your condensing water temperature set point and not have that linear program, or have it as a backup, but then just say, hey, look, AI, I want you to look at this point, this point, this point, this point, and your target is the best KW per ton, and it does it all by itself, and the longer it runs, the smarter it gets, to where, we're in the shoulder months or the winter time, we're seeing like 0.35 kW per ton for the entire plant, not just the chiller. And
wow,
ASHRAE says 0.45 is the best you'll get at a chiller. And I'm like, well, who gives a shit what the chiller is? Like I could go dump ice in the cooling tower if I want to get a lower number at the chiller. It's about the entire cost of making chill water, right? So the pumps and the tower and all that stuff. And so that's pretty exciting, right? That was that, like, wow, what else can we do now, right? We're matching condensing water to tonnage, right? So that we're not over pumping. But now the next thing is, okay, well, let AI loose on that, give it the high and the low, and say, look, as long as you stay within those parameters, why don't you try running less water? Because we learn now that a higher temperature at the cooling tower is many times more efficient than a lower temperature. And yet everybody is biased and programmed to say, look, no, you want really cold water for the cooling tower to make your chiller run more efficient. Not necessarily, right? And so we learned it by doing it and having the data to prove it. Okay, well, maybe matching, the cooling, the chiller was designed at 2,300 GPM condensing water flow for 1,000 tons. Okay, but not at 50 tons, right? In the middle of the night when it's running. And yet that's how they programmed it and gave it to me. And so we matched it. Okay, so now it's 1,300 to 2,300. But you know what? What if at 1,000 tons, 2,100 sometimes is the right number, right? And how do you figure that out, right? Well, let the AI loose on it, let it trend all the data, look at the KW per ton, look at the efficiency, and maybe we'll find out something new. We don't know yet. And then how does that work into the building side of things, right? What is the ideal discharge chiller temperature, right? Chill water flow temperature. Some people will say, oh, we did all these experiments and 42 degrees is the best. That's where you should run it. Yeah, but should I run it there 24/7, 365, right? And so we're not able to calculate that kind of stuff all the time. We can calculate a window. AI is able to do that all the time, right? And so just those thoughts, like you said, when you can't do something, right, it keeps you up at night, right, until you figure it out. These thoughts are now like, hey, Keith, come on, let's program this one next, let's see what happens. And so how will we use that to optimize the heat pump, right? We installed the heat pumps, and they were designed to displace the boilers 80% of the time, right? So we knew in the wintertime the heat pump wouldn't put out enough hot water, and we would have to turn the boilers on, hot water heaters, right? And yet as we ran them and experimented with, pushing the button and tweaking things, we finally, at the very end of the winter season, we figured out that, hey, you know what? I don't have to turn the boilers on and leave them on for the day. I only have to turn them on if the outdoor air temperature gets below 45 degrees at nighttime. Then I turn them on first thing in the morning, raise the temperature up to 155, 160, then shut them off again and let the heat pumps coast. 131, something like that, right? Take the chill off the building, build up a little thermal mass. And so now we're like, wow, next winter, we're going to be able to cut the hours even more, right? Because in the beginning, we would turn them on and leave them on until, 2 o'clock in the afternoon, forget about them. And now we're like, oh, wait. And now that we figured that out, then, hey, Jose, my control specialist, hey, can you write a program that says, if the outdoor air temperature gets, hits 44 degrees at nighttime, then turn these things on and run them up to 160 degrees and then turn them back off again, switch everything over, heat pumps are running and doing everything. What will happen once we start turning, Facile or AI, set it loose on that and finding out what's the optimum. And maybe it's not just 44 degrees, but it's also humidity or trend data or something like that. Maybe we add in the exterior average temperature of a building, right? Keith talks about building as a battery, right? So, figuring out what that thermal mass is that we have to build up to where then we need to turn on because we're going to need this much temperature. It's too many points for a person to, wrap their head around, but the AI is able to look at all that stuff.
It's interesting. So for our listeners, what Kenny was talking about a little bit earlier was something called cooling tower approach. So if you have cooling towers, you physically cannot get below the wet bulb temperature. Just the physics don't allow it to happen.
Yep.
And so what happens is that cooling towers are designed with that in mind, plus some dead band in between. So we call it cooling tower approach. Typically, it's anywhere between 5 to 10 degrees. But I've never really thought about taking cooling tower approach while you have that just sitting there like, hey, in case I need it, I've got this. But then taking all the other calculations into consideration to calculate like your condenser water set point, which I think is really interesting.
Yeah.
So what kind of temperatures are you running in there now? So instead of like 85, you're probably running like 92, 93?
No. We're anywhere from 5 to sometimes 20 degrees above wet bulb. So for us, our wet bulb, 58 to 65, right? Right about now. And so, if we're 65, we're probably averaging 9 to 10 degrees. Sometimes it goes really high. Right now it's doing some self-learning and stuff. So, it's dumping the temperature up and then getting some readings. Say, hey, that was good. Nope, that was bad, But it's exactly right what you said. So we used to have direct gas-fired absorption chillers.
Okay.
Right. We replaced them with electric chillers 6 years ago. But before that, we had direct, right? The temperature you run is very critical. You can't run too cold of water, right? And so when it was time to get new cooling towers, because ours were falling apart, we went around and I went out to a large studio in San Diego and looked at their towers. They had the exact same ones we were thinking about purchasing. And they have, we're using Tower Tech cooling towers. They have 8 fans under each one. They're designed for 800 tons a tower. I had two 1,200 ton, 2,400, I had two 2,400 ton I had absorption chillers, right? And I had like 2,400 tons of cooling. And so we put in 3 800 ton fans, towers. I didn't have electric at the time, right? So we sized them for that. Then I put in 3 1,000 ton chillers, and that first heat wave, I was only able to do 2,300 tons of cooling with 3,000 ton chillers. But going back, so we're looking at these things. We're talking to the guy out there, and we're trying to decide on the motor package. Do we want to be able to run each motor separately so that we could stage that, right? Or do we want to just not spend the money on the motor package and just one inverter turns everything on and off? And the guy there says, look, you know what? I bought that package, but the reality is I found out that, look, fan horsepower is way less than compressor horsepower. Therefore, he goes, I just run them at full speed, 100%, and we're just killing it. I go, oh, well, that makes perfect sense, right? Because this is me not knowing all what I don't know at the time, right? And so when we went to electric chillers a couple years, two years later after putting these new towers in, they're like, how do you want to run these? I said, you know what? Just enable them at 100%, right? Chillers going. These chillers now want cold water, right? Just run them at 100%. And so I ran like that for about 4 months. And finally, I'm talking to an engineer who I really, really trust, and I'm telling him how we're doing this and this. He's like, why are you doing that? I go, what do you mean? He goes, well, physics says the best you're going to get is probably close to 5 degrees above wet bulb. And I'm like, oh, well, he goes, and he pulls out the cyclometric chart and he starts showing me these things, and my eyes just glaze over. I'm like, I don't want to look this. I don't know what that is, right? And so, oh shit, that was an oh shit moment, right? It's like, well, why am I wasting all this? That's why my fan, yeah. Anyway, because I'm still aggressive, I'm like, oh, well, then if that's the best you can do, I want the best. So we set them for 5 degrees above wet bulb, and we ran for 5 years like that. And then we turned Facile on, and it's like, oh shit, that next moment where now we're, 10 degrees and 12 degrees and 13 degrees. And actually, when we first turned it on, we set limits. We set the guardrails that said, look, I don't ever want to be more than 8 degrees above wet bulb, 7 or something like that, right? And all of a sudden, Facil's bumped up against that, and that's where we're at all the time. We're like, oh, we'll raise it up 2 more, and then just bumped up against that, and it's like, just turn it off. Like, let it do whatever it wants to do, because again, what's the worst thing that could happen? Let's say the fan's turned off. What's the worst that could happen, right? I shut down on some fault because the temperature's too high or something like that, right? These things shut down on all kinds of weird faults. What the hell, right? And so, there's a lot of things we do because somebody that's been doing it for a while, that's how they always did it. Or, they run, we just set it for 85 degrees. That's our temperature, all the time. And it's like, well, yeah, but is that right? What if you're only doing this many tons? Maybe it changes. If the flow changes, maybe that changes. And so the AI is able to look at those different changes, right? And every 5 minutes, it takes a look and says, hey, you know what? I think we're a little better if we move this, 0.5 or something like that. And it's been cool.
So do you have head pressure valves on the chillers?
Yes.
Okay. Yeah, I mean that's also a good one there. I would continuously look at, I would do head pressure control in there. So like even if I decided to bump down, the condenser water temperature, as long as I was making proper head pressure across the barrel, then I'm like, I'm okay for now.
I mean, at the end of the day, the thing that I think everybody needs to understand about AI is that it's not going to. You need to know what your limits are. Right. And if you know what your limits are and you've got, safeties built in and you know what your limits are. So now you have physical safeties and you have electronic, digital safeties. Right. It's like, look, can we see the head pressure? If we can, awesome. Right. Now we can look at that and say, hey, look, don't ever get below or above this. Right. Yep. Can we see whatever, right? The temperature, like, look, I don't want to ever try and hit below 60 degrees. I don't ever want to try and go above 90 degrees. Right. Because I know that's, where I should be. On the flow, look, the chiller manufacturer says the flow for this 1,000-ton chiller is minimum 1,300, maximum 3,500, right? Okay, Facile, you can do whatever the hell you want as long as you stay within those ranges, right? And the worst thing that can happen is it runs inefficient. Well, I'm finding out that it was running way more inefficient before. We just didn't know it, So creating the guardrails makes life a lot, that's your built-in safety, right? Put a big e-stop on there so that, your facilities control specialist, if he sees something crazy, it's like, hey, push the button, right? Disconnect that stuff. We did the heartbeat monitor. If my system does not talk to Facile every 5 minutes, that 1 goes to a 0, and that statement then just falls back to our old inefficient programming, which, is better than the way we always did it, right? Must be good. But it doesn't shut you down, right? It just loses efficiency.
So do you give like Facile AI like prompts and stuff like that as well? Or, I know it takes, I know how it works kind of in the background where it's taking the data and then, it pumps out new information. But what I don't know is whether or not like you have the ability to like feed it things like, hey, by the way, blah, 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 blah. Or
no, I don't do that. But in the beginning, so it's self-learning now, right? It's built in that it makes those changes so that you don't just, this is a good number and it stays static and never changes. So I forget what the word is, infers, it does something, right? It says, hey, you know what, let's try this because we've been running like this for a while. Now, in the very beginning, I was the guy that tried stuff, right? We would run it, we ran it at 5 and let it try and look for things. And then it was running and then I'd see it running at something. And I'm like, what if I override that to 9, right?
Yep.
And if it was good, because Facile is recording that data, right, every 5 minutes, then it went into the good registry. And if it was bad, it went to the bottom of the registry or whatever it is. And so I did a lot of that in the early days, every so often I'm like, let's try this. Now, like I said, it's kind of built in. So, And the way the program was written was, its goal is 0 kWh per ton, right? And so that's what it focuses on, right? When it's making changes and stuff, it's looking at that number to try and hit the best number.
What's the biggest energy savings you've seen so far?
Well, the year that it ran 100% versus a year that we weren't doing any crazy stuff 2 years before that was, like I said, the average came out to 48% efficiency, increase in efficiency. So we went from 0.71 to 0.89 average to I was doing 0.35 to 0.55, and so it averaged at 4.8 somewhere in there, right? Something
wow,
like that.
That's it's quite a savings per year, actually.
Yes, it's great. So that the next year we did the heat pumps. Now my electric usage went up, but we're doing all the data, and so I did a spreadsheet because everybody wanted to know, well, how much more does it cost utility wise, for your heat pumps, right? Because hey, that's great, you're doing the right thing for greenhouse gas, but can we afford it, right? And so I got electric meters on all the heat pump stuff. I got electric meters on everything. We got the gas meter. We went and we took it was like September, October, November, December, something like that, and we took the gas therms and the electric kWh for each of those months, took the average, there's a number. And we did that for 5 years, 4 or 5 years, right? And so I sent it off to an engineer of mine, the one that told me that's physics, right? And I said, hey, Jay, I need you to look at this and tell me, before I post this online, I need a sanity check, right? And I had one number for total, how much more it cost, right? Mm-hmm. And his number was much less. And actually, it was more, sorry. And I said, Jay, it's math. Where did I screw up, right? Because he came back with a way different number. He says, well, I had to throw out last year. You can't use last year. He goes, because look at this. Your 4 years previous to that, you were at, I'm going to make up numbers, but let's say I was at, 130,000 kWh,
okay. Yeah.
average per month, right? He goes, and then the year you ran Facile, you were at 100,000. He goes, that's not a fair comparison for all this other stuff. And that was that other, moment. It's like, oh shit, we weren't even thinking about Facile. I hadn't done any of the math for that besides for, wow, look how good the kWh is, and it's like, it's right there in black and white. Because the heat pumps weren't running yet. Everything was the same. The only thing that was different at the plant was Facile was running that year. And those 5 months were, averaging, like I said, it was 30,000 or 50,000 kWh. I can't remember what the number was, but it's online somewhere. And so, yeah, it was big, right? And then we pay 26 cents a kilowatt hour. So it was a cool savings.
Yeah, I was going to say, I was like, that's I mean, I was doing the math in my head. I was like, that's a lot.
Yeah.
That is a lot. So what's the next project? Like what is the next big, if better, better is
possible, right? Yeah. Yep. So working with Keith to get Facile to do more things, right? We're going to go to the air side next, right? That's one thing that'll be going on in the side all the time. I'm working on another 1.5 megawatts of carport and sidewalk covered solar.
Okay.
That's going to be pretty exciting, right? That's going to, help with the heat pumps, right? And then I'm going after a grant with some people, that, maybe another megawatt of solar, 500 kW of solar with batteries to match, because once I do the 1.5, I will start exporting a little bit. And so now I need to store that up in the battery. I have written a letter of support and stuff to a company that wants to try and get a grant to do a electrolyzed hydrogen generator or fuel cell, right? To create the electrolyzed stuff. It's like, well, if I have enough solar to offset the cost of that, then to me, that's a no-brainer. And then the energy efficiency stuff, right? Now it's building up my team to be looking at all these sparks, and the Sky Spark stuff, right? And start fixing those one-off things that, well, it's just one, we got the whole campus to look at. It's like, well, I got 9 people. If I can get 4 of you that are focusing on this, I just did their employee evaluations, and I'm like, hey, look, this year I want you to fix 10 things on that Sky Spark report that we get monthly, right? 10 things for the whole year is not a lot, but it's going to start getting them focused and start, getting them involved in it. And so it's, creating energy champions that are looking at those, how can I move the needle 1 tick, right? And move 1 tick today and 1 next week and another 1 next month. And, before you know it, we're moving backwards again. So
that actually does bring me now. To my next question. So we've been talking a lot about AI, so the non-human element. Let's actually talk about the human element. So you were just talking about your team and certain goals there. And so obviously you want to play a big role in mentorship and training. For your team. So what does that look like in your mind? So obviously you talked about like the 10 things with Sky Spark, right? And obviously 10 things, while may not seem like a lot, could be massive depending upon what those, what those 10 things are,
right?
Yep, yeah, exactly. Yep. So what does that plan look like for you to continue to mentor in the role that you have for the people that work with you?
It's just more, probably longer hours for me, because I'll spend more time with the team in the daytime. And then when they go, I'll go home at 3:30. Then it's time to get done with the emails and the administrative stuff. Right. But this week, yesterday, I spoke to the lead BSC and I said, look, you know what? We've had a standing appointment 7:30 every Monday to go over what happened over the weekend and different things. And we've never used it. Right. I'm like, we're going to start meetings starting Monday, we're going to start talking about this stuff, right? I have another employee that, a BSC that, is really enjoying the controls and the using the AI to create these things. We have a network architect, BAS, that was, everything is on one system. And we learned that as the system gets bigger and bigger, that's not the right way to do things, right? So next week we're meeting with IT to develop a segregated plan where every building is its own separate network. And then they talk out so that when I do a backnet device discovery and say who is from the central plant controller, I don't look at every single building, right? Because we're crashing the things. And so as we do that, we're going to straighten out that network. That's going to get my facilities controls people involved, right? To see how things should be done. And so we set that precedent of the new stuff. As we start talking about, every month we get a report from Sky Spark with all these things. And it's like, I send it out to the entire team. Well, now that I've talked to them, it's like every month when that new report comes out, I'm like, okay, what are you going to work on? What are you going to work on? It's just spending time with them, right? It's trying to build that team to where, like, look, if you see something wrong, you don't have to be the guy that fixes it, right? We have a team, right? Maybe the BSE team goes up there and rips out those 5 pneumatic things for those VAVs and then slaps on the DDC, VMAs. And then the control guy comes in and hooks up the wires and programs it in, right? And so getting them all working together on these projects instead of, one guy being overloaded because, oh, well, that's controls, we're doing that. It's just what's the word? It's a culture, right? Trying to build that culture into, it's going to sound corny, but it's like, when I retire, I want them to still believe in Kenergy, right? This is the Kenergy way of doing things, right? One tick, right? Let's make it better. And so that's kind of it. I don't know that there's like this grand, Stephen Covey, perfect teamwork building plan. It's appreciate the people that you have, make sure that they understand the vision, right?
Yeah.
It's like how many energy champions are out there that are just awesome. They get stuff done. They go to conferences. They talk to people. They put presentations together. And then you step back one day and say, I've been doing this for like 3 years and I've never shown this presentation to my team.
Mm-hmm.
Right. And so we all of us from the BSEs to the directors and managers and stuff, we get focused in our lane and we do these things, and we need to be better at reaching out, right? Communicating this with, like you and I try and do, right? With other people to share, but also in your own team, we have to be better at sharing, right? So people know that they have a purpose, right? Like for me, it's really hard because I work for the state. They could go make more money somewhere else, right? So how do you get them invested to where, look, you own this, you get credit for all this stuff that you do. Own it, make it better, right? Show it off, put it on LinkedIn, do your thing.
So how do you, I was just about to say something. Yeah. So, one thing that you have very high standards. And, I resonate a lot with that because so one of the things I used to do, there's a card game called Magic the Gathering. And it's been around since '93. I still play it, not as much now, but for many years, I was actually a high level judge in the community. And so one of my roles was to mentor other judges to running events and whatnot. And I had a set way of, hey, we are running these events that way. So it's actually nice that even though I am no longer active in the community, that those standards are still being ran as they're mentoring now other people and running them that way. So I'll go to like a card shop and I'll see a judge there and I see, I'm like, huh. All right. And I asked him well, who mentored you? Oh, so-and-so. I'm like, okay, got it. So now I could see, that level of, that specific level, and that goes across anything you do. So it's whether it is judging for Magic the Gathering or, for your facility or my training and controls, we all have, we all want things to happen. So that way we implement good standards for those people who, but obviously there are people that, you need those people to have motivation, right? And there are ways to, there are ways for people to have self-motivation, right? You have to be some kind of self-starter, but what kind of ways do you motivate your people into becoming those champions that you want?
I don't know. I do it. I like to think I do it because, like I said, I have a very high performing team that seems like they tell me they're happy, right? And so, when they do good things, I'm patting them on the back and telling them when I go to conferences, I try and give credit to the team, right? It's like, look, I don't do these things, I mean, I lead, right? I come up with suggestions and stuff, but these are the guys that are getting it done, And so I make sure that they get credit for things. I support them. But at the same time, when they do bad, if they do stupid bad, that's a little more complicated. But if they're, if better is possible, right? If they do something that I think was stupid, it's like, hey, come on, dummy, what are you thinking, right? And so it's about building, it's 30 years ago, management styles was never become friends with your employees because you can't, and I don't think that breeds happiness, right?
Yeah.
People got to not wake up in the morning and go, oh, shit, I'm going to work. Like I want them to wake up in the morning and go, oh, we're going to find out, I'm going to go on ChatGPT and figure out, how to create this blah, blah, blah. Right. And so it's more about creating good morale. Right. But you also have to, I don't think micromanaging is the way to do it, right? You have to here's what we're going for. Like today when we looked at these VAVs that we're going to have to, fix and stuff, I'm like, oh, okay, well, how are you guys, going to do that? This is what I would do. But, oh, no, there's an access panel on that side. And, maybe we got to cut a hole in it. Look, it's just mechanical. We get it done. I go, okay, cool. All right. You guys work on it this weekend. And then on Monday, we're going to do this. What do you need from me? Right. And so it's being there when they need you, being there in the beginning, right. To focus a little bit, but then letting them do their thing, right? And appreciating what they do, right? And so if you appreciate everybody in the whole world wants to be appreciated, right? And so make sure you take the time to appreciate your people. Take them to lunch, 3 times a year. It doesn't have to be every day, right? And if you can get the campus or whoever to pay for it, great. But you know what? Does it really bankrupt you if you got to spend $100 out of your pocket to appreciate the guys that make you look good? Don't be selfish, right? We're all here. Make sure they know it. That's kind of how I think, it's been working out. And then, like I said, once I started actually sharing with them, right? I did that. I got an hour presentation that I do for all these things, right? And it's like, I realized one day I didn't do it for my team. And so one week we went through that, and my facilities control specialist shocked me. He says, dude, we could do better. And I'm like, oh, okay, we're there, right? It's like, and so whether they do better on their own or whether they don't whine and complain when I tell them, hey, what if we did this, right? Hey, could you write this program that's going to take you 4 days of testing and figuring it out and then you get it all done, and then I'm like, oh, that's awesome, but what if we did this now? I like if we were together, I know they'd want to smother me with a pillow, right? Sometimes, right? Because it's just like, but at the end of the day, it's like, look at these results, right? They're proud. They built that. They did that. All these crazy things we've done has been with the team I have now that, they can take ownership of all this stuff. And so, let them know that they're awesome.
Yeah, no, it's a very good thing there. There was a kid I mentored. He is now a developer for a company, and he works with a lot of AI stuff as well. But I will tell you that he came to the company I was working for because he wanted to be mentored by me. And so he was talking to a few of the other senior programmers there, and they were like, "Look, I don't think you understand. He's going to be really hard on you, but he does it because he cares. However, if you screw up, he's going to get to the bottom of it. And you guys are going to have some hard conversations about it, but you're going to understand that you're going to be better at the end. But he really does care." And so they actually kind of trolled him a little bit. They're like, well, what's he like? I want to impress him. So he got there early, and they're like, yeah, you want to go ahead and put these presentations, put these control drawings in these books for him. He really likes that kind of stuff. And he doesn't like long piece of paper. So instead of the 11 by 17, you really want the 8.5 by 11 and whatnot. So I go to my office and he's there and the other 2 senior programmers there because they didn't want to miss the fireworks. They really didn't at that point. He's like, "Hey, Charles." I'm like, "Hey, so-and-so, how's it going?" And, he's like, "Yeah, I've got everything here that you like. And I hope this is up to your standards." And I pick up a book. I'm like, "What the hell is this?" And he's like, "Well, these are your control drawings." I'm like, "An 8.5 by 11?" I was like, "I can't even read this right now." So literally I took the books and I threw them in the trash. I'm like, "You're going to go right now to your laptop and you're going to print out 11 by 17. And if you don't know how to, I'm like, go ask someone to show you how to print them out in 11 by 17. I was like, don't ever give me 8.5 by 11 on control drawings ever again. I was like, so he quickly walked out and the 2 other senior programmers are laughing. I was like, I know that you put them up to this. I was like, otherwise, I probably would not have been as hard on him on that particular thing. Normally we wouldn't do that. And so there are sometimes where I'm like, hey, you did a stupid. We know you did the stupid, especially if they feel bad about the mistake they made, right? I'm not going to beat them up at that point. Right. But hey, we know that we did wrong. So let's see how we don't do that stupid again, right?
Let's learn from it, right?
Yep. We have what I call ID 10T moments. And so if you take the I, you put the D and then put the number 10 and then the T. If you write that out, it's the idiot moment. The ID 10T error.
Took me a minute, but okay, got it.
Well, some people are like, oh, identity? No, that's not what I said. That's not what I said at all. And so like I'll write on the board and some people will get a chuckle. Like it'll take some people at first like a little bit to think, like, yeah, okay, got it there. I like it. Kenny's gonna start doing. He's like, yeah, look at that, guys. There you go. Like this is your ID 10T error for sure.
That's cool.
Well, Kenny, you answered all my questions and then some. And so I really appreciate you taking the time out of your day to do this, because I know, your day started early. And so you've taken time afterwards to really kind of hang out and kind of talk things about the facility side. And so I'm glad that we had this conversation, because I know that some people probably, I don't know how many facility managers that we have, or directors in our listening. In our audience right now, but hopefully they now get to see that side of how things, are done at that part, and they gain a little more insight. Yeah. So I really appreciate you taking the time here.
No, I was happy to be asked, like you said, right. It's about sharing, right. It's about giving back. You guys, I didn't know who you were up until, you invited me, and then I went and listened to, a bunch of your podcasts, and I'm like, oh, these guys are fun, and like, this is good stuff. This is live stuff, we spend too much time in that corporate world where, everything is so politically correct and hush hush, and, don't endorse this and don't endorse that. And don't, I'm like, yes. Right. And so it's refreshing to be able to just, hey, we're just having a conversation here. Right. It's like, this is what works for me. And, if I can share something, that's great. It's all fun. So thank you.
No, you're very welcome. Well, guys, that's all we have for this episode. Remember to stay curious and keep striving for better. Until next time, I'm Charles.
And I'm Matthew.
And this has been It's a Controls Problem. All right. Hello and welcome, everyone. Charles Johnson here. Hold on. Oh, my God, that's terrible. I don't know what's going on right now. Okay.